This is the briefing for the sodium borohydride reduction of benzophenone. So this scheme here shows the overview of the reaction you'll be performing. You're taking benzophenone, which has got a ketone, and then using sodium borohydride, you're reducing that ketone and converting it into an alcohol. And so the purpose of this experiment is to give you practice of performing these laboratory skills. So safe working practice is something that is part of every experiment, as is learning how to use and record your experiments in a lab book. And then what you'll also be practicing in this particular experiment is practicing how to do a vacuum filtration, how to purify your product using recrystallization. And this experiment really introduces thin layer chromatography, a key technique for analysing purity. And so in this case, you're going to use it to monitor the progress of the reaction to see if the starting material is converting to the product. And then also infrared spectroscopy, which is a key technique for analysing the structures of organic and inorganic compounds and working out if you've got the correct structure. So you're going to use it to work out if you formed your alcohol, or if it's just remained as your ketone starting material. So as part of the pre-lab exercises, you have videos to watch of how to perform these key techniques, such as TLC and IR. So do watch them. They will help and ensure that you do these techniques correctly in the lab, which obviously will then ensure that you are successful with your experiments. Okay, so make sure you read the script and look at all the details and roughly work out how long things will take for each sort of part of the experiment, so you can plan your time. But this is a general idea of how the reaction should pan out. So the first thing you're going to do before you actually start the reaction is you're going to have a practice of setting up and running a TLC plate. It will just be of benzophenone on its own, so it's just like a practice run. And then you're going to start the reaction itself. Okay, and then you're going to run another TLC and monitor the reaction to work out if it's complete or not. If it's complete, then you move on to the workup stage, where you're starting to try and purify your product. But if it's not, then you just simply leave the reaction to stir for longer, and then you just run another TLC until the reaction shows that it's complete, and then move on to the workup. I put in a nominal lunch break in here, but it's up to you to take your breaks whenever you wish. And then after you've done your workup, you should have a crude product. You're going to purify that sample even further using a recrystallization. And then after you've done your recrystallization, you should have a pure solid, and then you've got your analysis, such as with the IR spectroscopy, to get an IR spectrum and look at that spectrum and work out if you've got the correct product. And then there's also some extra time planned in for experiments. So if you need a little bit longer for the experiment, then you should still be able to complete it comfortably within the day that's planned. Okay, so hazards and disposal are really important for this experiment. You are going to be handling hazardous chemicals, and so all the details of the chemicals you're using are in the experimental script. So make sure before you handle any of these chemicals, you look through the script. Make sure you understand all the information about how to handle the chemical, what precautions you should take, and how you should dispose of it before you are about to use the chemical itself. So this is just a summary of the key hazards of the chemicals that you're using, but it doesn't cover all the details in the script, so you need to still read the script to handle them safely. So you're going to be handling some flammable chemicals, so things like ethanol, ethyl acetate and petroleum ether are all organic solvents which are flammable, so you need to make sure there's no naked flames or sparks near them. You're going to be using concentrated hydrochloric acid in the workup stage, which is very corrosive, and so you need to make sure that you've got your gloves on, and also when you're disposing of it, that you actually dilute this concentrated acid down to become a weak acid before disposing of it down the sink. And you're going to be handling sodium borohydride, which is toxic if you ingest it as well, so you need to be really careful when handling that particular chemical. Okay, so these are some tips to help you perform the experiment well. So the first set of tips are related to making sure you perform the TLC correctly and get a nice sort of TLC analysis. So I've got a diagram of the TLC tank that you set up here with a beaker, watch glass, and some solvent in the bottom, but also make sure that you add in the filter paper as well. Okay, it's one of the most common mistakes that students make is that they forget to add in the filter paper. Now, the purpose of the filter paper is it helps your TLC plate run more quickly. Okay, so it's not that your TLC won't run if you don't add in the filter paper, but you just end up having to wait around for longer if you don't add in the filter paper. And then when you're analysing your TLC plate to look at the spots representing the compounds, if you find that your spots are what you want to achieve are nice, small concentrated spots, so you can see good separation of different chemicals on the plate. So if your spots are too big, it's hard for you to see which ones correspond to starting materials, which ones correspond to products. Okay, and that's usually because you've got too much sample that you put onto the TLC. So what you can do is you can dilute your sample by adding a little bit more of the TLC solvent that you're using, and then when you spot it on, you've got less compound that you're putting on the plate, and you should get a smaller spot. Conversely, if you haven't put enough compound on the TLC plate, then you'll find it very hard. You'll find it hard to see it under UV. And if that happens, then all you do is you spot it more than once on the TLC plate. Normally, you just spot once for each sample on the plate, but just spot it 2 or 3 times if your spots are really weak. All it does is you'll just end up putting more compound on the plate, so you'll be able to see the spots more clearly. And then finally, just a little bit of advice about the recrystallization. This is general advice that you should always do with all recrystallizations. Make sure you use the minimum amount of hot solvent to make sure you sort of crystallize out as much product as possible when you cool your solution down. Okay, so if your solvent isn't hot enough when you add it to your crude sample, you'll end up adding more solvent than you need to, and so you'll get sort of a lower yield with a lower amount of precipitate forming as a result. Okay, so make sure your solvent is as hot as it can be before adding it to your crude sample to dissolve it up, and then you should get better yields as well.